started looking at it last time, we had seen that there are 4 strategies: abstraction, separation, composition, and generalization. We had looked at the first 2 last time, so first thing we'll do is look at the other 2 today and complete that part, because that's going to be on the midterm, and then as time and as much time is left, start talking about inheritance. Okay, I'm just trying my luck one more time with the projector, but I think, yeah, the projector will probably not work. We had this issue. I think it needs the replacement of the lamp and the filter. So we'll do it the old-fashioned way. So we'll use the board instead. Okay. I think a couple of you had mentioned about the iterator sample code and the code that we looked in the STL class. It was posted. I know I was confused too, but it is a zip file, so it contains all the PowerPoint, all the code, and the iterator. So I checked on it, so that is in place, and the sample quiz is posted. There was a delay. I intended to do it earlier in the day yesterday, but it got done in the night. But you have that also. So basically, anything else that I owed you, or are we good? Yes, good. And then I have got a couple of requests to make the midterm simple, so I'll keep that in mind. Now I haven't made it yet, so I will definitely keep it in mind as I put it together. Okay, so then let's continue with the OOP theory. What I will do is I will look at slides and put the necessary information on the board so that we can get that. So as I am going through the slides here, just reiterating what is expected from you from the midterm point of view. So know your phases of software development. Okay. Then know some goals of object-oriented programming. Not the whole list, but at least 3 to 4 goals. Know all your design strategies, so the abstraction, separation, composition, and generalization. You should be able to define them in your own words. I don't need exact wordings that are there, but I do expect you to know. You should be able to give examples of each if I ask you to. In the past, I have given you an example and asked you to use these strategies. Given you an example and tell me where these strategies have been used, So in other words, for preparation, know what these strategies are, be able to tell your friend what abstraction means, and be able to use an example to tell your friend what abstraction is. I think that should be, if you can do that with all 4, that should be good enough, in whichever form the question comes. So and in terms of abstraction specifically, know the properties of good abstraction, which were that it should be well named, it should be coherent, it should be minimal but complete, and it should be accurate, right? So that's something to know from there. Same thing for separation. Know the definition, be able to explain it with an example. And then this is slide 13 out of the 30 slides that are there, so which talks about how the real world entity becomes a software, the attributes become classes, that mapping all the way through, the private section, the public section, the separation of interface, and the implementation. Then we said you will have again working definitions, how you would be able to explain what a class is, an object is, and encapsulation is. So those are some keywords, important terminology related to object-oriented programming. I skipped the interface slide, so I'll talk about it a little later. And that brings me to composition. Okay, and as I go along, I will talk about what composition is. So the third out of the four strategies or techniques: abstraction, separation, composition, and generalization. We've looked at that. This is what we are looking at now. So again, on the same note as the other two, tell me what you understand when the term composition is put on the board here. What has composition, what does the word composition mean to you? Whether in software context or out of software context, I don't care. I just want to know, what does composition mean to you?
Make something out of different things.
Make something out of different things.
Combining the entities.
Combining the entities, yes. What else? To me, it brings vivid memories of elementary school English, when you had to write 5 sentences about your favorite friend, right? That is what composition brings. That's the memory that composition, the term composition brings back to me. Again, at that point in time, it was a composition of ideas. We started very basic, saying, okay, give 5 sentences. Then those things became essays, right? Small, shorter essays and longer essays, and then so on and so forth, right? So yes, what we did was it was a combination of our ideas on those things. So combining different things. That's what composition is. So absolutely right. Composition means combining. What do we have here to combine in the software world? What are we going to combine?
Modules.
Modules, yes. What else? Packages. Or like packages if we are talking in Java, modules if we are talking in C++, Lingo, classes, right? So classes give us data types. How do we combine them? Can you give me an example?
Combining classes. Inheritance.
One way, and we'll talk about that in terms of generalization. You have used it. Inheritance you haven't used yet. So what would you pick up as an example of composition?
STL.
Be more specific.
Using one STL class with another template from different classes.
Yes. So if I'm using objects from 2 different classes to solve my problem, that's a composition. Any program you wrote has been a composition. We haven't used the term composition. We said write a program and didn't say compose a program, right? But you have been composing, right? So what have you been using to, so once given a problem, right? The most recent being finding whether 2 statements can undergo concurrent execution or not. That was the problem. How did you solve it? By putting different things together. And what were these different things? These could be objects from different classes, right? So that is an example of composition. As we go further into the details of composition, we will find that composition is 2 kinds, okay? Association and aggregation. Association is loose or is less, I don't want to say integral really, but it's loosely combined. In aggregation, we have a stronger combination. Here, one is, or we call it part of the whole. So, the examples we were talking about were more like association. But when you create, let's say, a matrix, right? We had a matrix of integers, but we could have had a matrix of another data type called cell, for example. You had a cell class, whatever it had in itself, and then the matrix was a two-dimensional array of cells, right? So when you declare a matrix object, the cell objects are automatically declared because it's part of the matrix. Then it is a stronger composition, and that is known as an aggregation. When we declare a lot of objects and they work together to solve a problem, like for example, any main function you write, and as many objects you write, they are working together to solve the problem that you are trying to solve in this main program. That is association. But when a class has another class as objects, so that when I use the object of the outside class, then the inside objects are automatically declared, that is an aggregation. Okay? If the example that your slides show is that of a computing system, a desktop system, right? Assuming that the disk and the CPU are sitting in the, registers and the hard disk are sitting inside the CPU, that is an example of aggregation. The fact that the monitor and the mouse and the keyboard and the CPU together give us this desktop computing experience, we are looking at association. So in case of association, things can be easily exchanged. But in case of an aggregation, it's not that easy to exchange because it's part of the definition. So that's what we talk about composition. And you have used composition in both its forms. If you only wrote a one module program, you are most probably using association. Okay? Can you still be using aggregation? Yes, you can. You might be using an object of a predefined library. It's not your second module, but you are using a library class which itself might use aggregation. So you did not use it as you write your program, but that object is using aggregation. But you could have defined your own module, like we said, a matrix class where it was a matrix of cells. Again, how we designed our second program, it could have used aggregation. If your post boxes, depend on how you implemented your post boxes. If your post boxes were an array of integers or characters, you probably weren't using aggregation. But if your post boxes would have been a matrix of a box, let's say, for very want of a better word, then if there was a box class and then a post boxes class maybe, then that could have used aggregation. Yeah.
Say if I have an object which is shared between multiple entities, so whether it comes in the association or aggregation, sharing.
Give me an example. I think none, but let me make sure that I understand what you are thinking. Are you saying you declared a class, right? Now an object of this class is used in program 1, and an object of this class has also been used in program 2. Is that what you mean? Then you are using no composition, because program 1 is its own entity, program 2 is its own entity. They happen to use the same object, but they have nothing to do with each other. Then there is no composition. If they are part of a bigger software,
like for a DLR or something.
right, If they are part of a bigger software, then it depends. If both of these are used somewhere together, then there is association. As in your description, P1 has nothing to do with P2, and they just happen to use the same thing, then this is no composition by itself. Okay? But if P1 is using object of your class and objects of other classes, then those three, let's say it's using objects from 3 different classes, then those 3 objects are working in association. Okay? So it's something like, you as a person, right? You are a student in the university, right? And you might also be a brother to your siblings, right? Does that make it an association between the university and your siblings? No. Right? But if 3 of you are students in the university and team up to get something done, right? Or are working on an assignment together, that is an association. So if you are doing your assignment 3 in pairs, that is an association. None of you owns each other. You are working together to get something done. Okay? If I hired a company to get something done, for example, and that company and those employees are working because they are part of the company, now the company at some level owns those employees, at the employee level, not saying you're a slave, but that you're an employee. So that would be an aggregation. So a company is an aggregation where your employees are part of that company. Okay? So, at the tricky thing with association and aggregation is what level you are looking at. So, if I pick up that example from the desktop computing system, if I look at it from the level which I described, that I see the monitor separately, the keyboard separately, the mouse separately, and CPU separately, and I see them associating to give a computing experience, I'm calling that association, and everything contained in the CPU as aggregation. If I take out that CPU part and now look at the registers and the cache and the hard disk and the primary memory and all that is contained in the CPU minus the outside box, then they are associating with each other. But the CPU as the containing part is an aggregate of those, because that is what is called a CPU. Okay, so those things will help you identify whether it's an aggregation and an association, and if both the things are coming to your mind, then see if something is owning the parts, because as I said, the same components can be an aggregation at a certain level and association at an inner level. So you want to see, that's the part you want to see. Again, questions will be similar. I could give you examples, ask if you see aggregation or association. I could ask you to give your definition and an example to show the difference between each, So again, I think as part of preparation, if you can tell another person what this means and explain it through an example, you are prepared. There's nothing else to do really. This is simple stuff, but make sure you understand it deep enough to be able to show that. Here is the definition that is in your slides. Composition is an organized collection of components interacting to achieve a coherent common behavior. It's a little more sophisticated language, but I think the meaning is what we were talking about. It refers to building complex whole systems by assembling simpler parts. There are 2 forms: association. Association is also known as, I think those are good words. Another way to know it is they use the term acquaintance, and here they use the term containment. Okay? Then the definition of association is given as the composition of independently constructed and externally visible parts. Parts may be shared between different compositions, parts may be dynamically changed. You know, mouse is not working, change it. You want to use the mouse from another desktop system, you can pick it up and bring it here. So they can be used commonly. You might have one mouse between your tablet, your laptop 1 and laptop 2, and you just, whichever one you are using, you bring this mouse. It can be shared, right? It can be dynamically changed. That's because it's a loose acquaintance kind of. They work together, but one does not own the other. A very simple example is you working in different groups in different courses. None of these groups owns you. You are just associating with different people. Same thing, you know, when you work, you know, that for me, I associate with my colleagues on different projects, right? You are part of different committees. But there is no containment. The containment is UB, right? That at a level, you know, you are a student of UB, or I am an employee of UB, so to say, right? UB will not be UB without us. So the identity of UB is its students and employees and staff and faculty. So that's where the containment or the aggregation comes. Aggregation is defined as a composition that hides or encapsulates the parts of the composition. Okay, any questions, any part of composition that's not clear? Okay, so then let's move on to generalization. I'll put a check mark here and take us to generalization. What do we mean by generalization? Unlike composition, I really cannot think of, you know, anywhere. I mean, in general, basically generalization would mean if you are looking at a lot of things, right? What is a way to order them? You have a lot of raw data, right? First thing that comes to mind is there a way, you know, it's like you walk into a room with a mess. How do you clean it up? And I have a vivid picture of my kids' room with all the toys all around. I mean, when you have a 5-year-old who loves to throw toys, you know, you'll reach there in due course of time when you are ready. But you know, probably remember me when you look at those toys and trying to clean it up, right? You know, you might have a bin where you throw them all, you might have 3 where you kind of sort them, but in general, how do you organize this random information? In terms of software, we might look at information, there is a lot of data, what do we do with it, right? One way that might come to mind is you say, can I make, instead of this big huge mess, smaller piles? And then I will worry about what I can do with that one, and so on and so forth. So is there a way to give structure, right, to all this information? Is what we are looking at. Now let's say you have, I don't know, let's say a lot of marbles. What is the way you could organize them? You could sort them by size, you could sort them by color, right? You could sort them by material if they are made of different, you are looking at marbles of different kind of materials, right? So you look at what is common in these things. If we take the student body in UP, right, we could divide them based on the school or the academic program they are in, right? Is it the School of Engineering? Is it the School of Education? Is it the Arts and Sciences? Is it the School of Chiropractic, or so on and so forth? Within our own school, are you an undergraduate student? Are you a graduate student? I could have done that before in the UB, undergraduate, graduate, then go into schools. So so another thing to see is there is not necessarily only one kind of structure. Depending on who is looking at it, might be thinking of different kind of structures. Okay, and then you see the merits of one, compare the merits of one with the other, and then zero in on a better structure if there is one. Okay, so basically we are trying to organize, give some structure to a large amount of information in whichever form it comes, kind of, right? So that's what we are doing here. It says generalization is defined as the identification and possible organization of common properties of different entities. And there are three forms of generalization. And we have looked at nothing right now, so that's why it's comparatively new. One strategy is to use inheritance, polymorphism, and design patterns. Okay. So finally, before the midterm, we see the term design patterns on the board, right? And we'll get nearer and nearer to it before we jump completely into it. But here are two more things we have to learn before we start talking about design patterns. Design patterns are nothing but, I don't know, I want to say what templates are to functions and classes is what design patterns are to inheritance and polymorphism. You know, things that are useful, you made a template of it, and you created the actual structure later. Things that have been found to be very useful have been made into design patterns. I think the one that all of us can relate to is the client server, right? We use it so often, any kind of chatting application. It's even more used now with the service-oriented architecture kind of a thing, that became a design pattern. So some common structuring using classes and inheritance and polymorphism that has been widely used has been translated into design patterns. Okay, so starting on with inheritance. An example I was giving you was pretty much inheritance, right? So if I have a UB student, actually I should. So everybody is a UB student. You might want to say whether they are undergraduate or graduate, for example. If they are graduate, you want to see whether they are coming from the School of Engineering, School of Education, chiropractic, right? What other graduate school we have? We could go in that. Business, yeah, MBA, why not? Right? And then, you know, or maybe let's leave it as School of Business. And then within School of Engineering, where we belong, you know, computer science, computer engineering, mechanical engineering, etc., right? And so on. So what did we have? We had a lot of students. And we said, you know, is there a way to categorize or organize this information about students? Because, you know, and what would it depend on? It would depend on what we have at hand. You know, sometimes it might make more sense to divide them in undergraduate and graduate level first. Sometimes it might make more sense to go into schools and then see, because let's say School of Engineering students, whether they are bachelor's or undergraduate or graduate, need access to engineering labs. So if we are talking about lab access, maybe the schools come upper in the hierarchy before we specialize. As we look in a hierarchy, as we go up, right, things are getting more general, or we say generalization. As we go down a hierarchy, we look at specialization. And what is known as, it shows and is a relationship. A school of a master's student in computer science is a UB student. A master's student in computer science is a School of Engineering student. A master's student in computer science is a graduate student. So this entity satisfies any of these three. A school of engineering student, whichever